So we were talking about tree implementations, and the first question we asked ourselves was how to represent child nodes. And we came up with a clever scheme, and basically we said that the child nodes would have their own list. And see, if you can look at it this way, you see that it is actually a list, just like we've defined it earlier as an abstract data type. And each node would refer to the next one as its next sibling. And the final one would refer to the next sibling null, and so we know it's the end of the list of these children. And the second thing we're going to be looking at is we're going to define a tree recursively, a rooted tree. So the way we're going to do it is we're going to say that a rooted tree is a collection of nodes. That's obvious. And if it's not empty, then it will have one unique root node plus k subtrees. So if you look at it this way, okay, and you can carry on with the children nodes, what we're going to say is that it's a collection of nodes, and it has one unique root node, and it has a collection of subtrees. Each one of these is actually a tree itself. And these trees, their root nodes, are actually the children of this particular node. And then for this particular tree, you're going to apply the same definition once more. So you go back to that same definition. You're going to say it's a collection of nodes, which has a unique root, and the children of that root become roots of other subtrees, and so on and so forth. So this is a recursive definition of a rooted tree. And this will help us because now we realize that we could implement a tree simply by looking at a node and defining a node. So this is one particular implementation. We say that we call it the tree node, the class, and this is the type of element that it could have. So the first thing it would have, of course, is an element itself. So we'd be referencing an element. It must contain something, the node. And then we could have a parent pointer. So we would have a pointer to the parent tree node. So if we looked at it this way, and this was our tree, then we would have a pointer that, and then we were looking at this particular node, then it would have a pointer to an element, which defines what it contains, and then it could potentially have, this is optional, a pointer to the parent node, and it will also have a pointer to the first child, and just like we said up there, first child, next sibling, it will have a pointer to a next sibling. So it has a pointer to a first child and a pointer to a next sibling. This next sibling will actually allow us to trace the children of the parent node. And this node, when we look at it, it will have a next sibling pointer, and these children are all children of this parent node. So this implementation actually allows us to go through the entire tree using these pointers. And the only mandatory pointers here are the first child, next sibling, and the element itself. The parent is optional. So if we actually define the parent pointer, then we have a doubly linked list. Okay. So there's actually two lists here that we're looking at in a way. There's the siblings list. Okay, this is the sibling list, and we also have the parent first child relationship list. So there's this particular list that we're looking at, the parent and first child, and the siblings list. So it's sort of like a superposition of two lists, which gives us the tree. Depending on whether or not we have a parent pointer, then we would define a doubly linked list or a singly linked list. So if we only have the first child pointer without the parent pointer right here, then it would be simply a singly linked list. And in terms of the siblings, we usually just use a singly linked list because we don't need to refer back to the previous child. We only need to find the next sibling. But you could also have another pointer that goes backwards and define a doubly linked list, like we'll see. So in Java, we have three implementations. We could use for the children's list, so these, we always have them right there. This is optional. This is the element pointer. And for the siblings list, we could use just a linked list that is provided to us by Java, or an array list, or, just like I showed it right here, we could actually define our own pointers and implement the list itself. So of course, the advantages that come with number 1 and 2 is that they're easier to program. You don't have to worry about the implementations of the list, but there are some disadvantages. It's slower, and it could waste memory, whereas